Hey everyone, welcome back. This is Vivek Bharata. Back in the early days, I've gone through a pain of understanding why my APIs are being slow in response times, and surprisingly, I see many mid-level developers struggle to find the root cause of bad API performance, where it takes seconds or even minutes to respond. In this video, we'll be covering top 6 ways to make your API performance 10x speed. Before we start, please note that optimizing an API is not the starting point of it. You should first understand what is the root cause or bottlenecks for the bad performance. Let's get started. First one is very obvious, that is caching, which is also a most effective way. It can improve the performance of a GET request significantly by considering query parameters as well as part of the cache key. And all this we can do with a very simple if-else block to get started. So in this example, let's say there is a GET request where it has a lot of computational logic in this block, right? So the normal request where it comes from client to server, it just processes the whole business logic out of it by reading all the necessary data from the database and send it as a response, right? Now, when you add caching logic, so whenever a client requests a server, first we'll verify based on how the cache key is derived, like let's say for the get list of users, along with some query parameters like sorting order, or maybe the search key like the username starting with so and so, or an email, something like this, right? So we derive a cache key, and based on that, first we'll verify whether there is a data in the cache server. If it is not there, then we'll first read from the database, update the cache with a key, or basically create a record and send the response. So this happens for the very first time if the cache key is not there in the cache. But in the following request with the same matching query parameters and basically the cache key, instead of doing all the computational logic along with the database reads, the server can simply return the response as is from the cache server. So this cache, as an example, I just written inside the server. It can be a memory cache or it can be a fully distributed cache system like Redis. That's all in short about caching. Moving on to the second tip, I would highly recommend to watch my previous video titled Top 8 Best Practices for API Design, which can act as a foundational concepts before watching this or continuing this video. Alright, moving on to the next one, that is pagination. Let's say if your API returns a large amount of data for a single request, like a user feed or thousands of transactions data. It's always better to send in chunks like 10 records or 20 records or even 100 records at a time, instead of sending 100k or 10,000 records of data or any large volume of data. This pagination concept is there for a very long time, and it's always visible in the Gmail application. When you open the Gmail of your inbox, you will usually see 10, 30 or 40 or at max 100 emails at a time. If you want to go to the next 100, you need to click the pagination like next, previous and all. So that's a very simple example. You can just go through and just re-verify how the Gmail pagination works. So in simple example, let's say for a user, the user emails are about 100k. So when user logs in, if you want to show all the emails, it's not a good idea to throw 100k records all at a time, right? It's an obvious, but usually most of the developers don't care about the pagination unless they hit this bottleneck. So instead of sending 100k records at a time in a response, so client can pass a set of query parameters like limit and skip. So basically limit starts with 100. It will be constant, stay as 100. So anytime the server will make sure that it will return only 100 records. And there is a skip option. So in this request, let's say the limit will be 100 as always and the skip will be 0. We are asking server to return only 100 records starting with 0. And in the following request, let's say the client will pass limit as 100 as always, and skip value will be 100. Server will basically skip the first 100 records and send the next 100 records. Simple. This small improvement can increase response times and also significantly reduces load on both server and client. That's it about pagination. Moving on to the next one, that is DB connection pool. In simple terms, this technique is maintaining a pool of connections or a set of connections rather than opening a new connection for each and every database query. Your backend service can seamlessly get connections from the connection pool, perform operations, and return the connection back to the connection pool automatically. A connection pool helps reduce application latency and the number of times new connections are created. Usually, a connection pool creates connections automatically at the start of the backend service, and application services do not need to manually return the connections to the pool. Instead, connections return to the pool automatically. So in this simple demonstration, you see for each and every query, the server is trying to open a new connection to the database, which is bad practice. So when you set up a DB connection pool, this connection pool will make sure it will return a set of existing connections to the server so that it can use that connection to do the necessary DB operations. For example, when you are configuring a MongoDB either via connection string or as an options object, you can pass the connections pool configuration. That's it, simple. Moving on to the next one, that is n+1 problem. The problem arises when an application makes one query to fetch a list of items and makes an additional query for each item in the list of count n. This leads to n+1 database queries, which can cause significant performance degradation, especially as the size of dataset grows. So in the simple demonstration, if you see the n+1 problem, here 1 represents one query to get the list of authors, let's say, and the list of authors count, assume that is n. This n and this n is same. So after you get the list of authors with one single query, so for each author, if you want to retrieve a list of books for that specific author, so you end up querying n queries to get the books for each author overall. So first server requests to get the list of authors of total count, let's say 10. Then in order to get the list of books for each author, you will end up calling 10 DB queries, which is a bad practice. This is not an obvious mistake where most of the devs use, but occasionally I did see this pattern from the developers. And usually this pattern happens indirectly from the database ORMs or ODM models, where inside, if the database is not supporting out of the box, like let's say for this scale, you could simply use a join query, assuming that authors data is in authors table and books is in, of course, on the books table. You could just simply use the join query to combine the whole query so that you can get a list of authors along with their books in one single query. You can actually make sure what exactly happening by enabling the database logs and monitoring those for all the set of APIs where it is like a get list of so and so entity pattern. And based on that, you can confirm whether the ORM indirectly making this n+1 problem and how you can actually prevent this thing. And there's another alternative way which is not ideal. In the case of database is not supporting join queries, you can first retrieve a list of authors. This stays as is. So in the response, let's say you got 10 authors list. So you'll collect the author IDs, you will create an array of author IDs, and you'll pass another query to get all the books with an inquiry of this author IDs. And then once you get the books for all the authors of this inquiry, you'll basically do the business logic to merge authors list and books list based on the author ID. This is not a good practice. We should always make sure that most of the business logic, if database can handle, we can just use the database level, not to pull from the database and explicitly handling that as part of the application business logic. Alright, that's all about the n+1 problem. Moving on to the next one, that is compression. So in case of higher payloads across the request and response, you can enable a request compressions like gzip or broadly, where the whole payload size from 100 KB can decrease to 30 KB. And you can configure this at the application server level. Let's say if Express.js is being used, we can have the middlewares configured, or it can be at the proxy level, or even it can be at the cloud config level. Simple. By enabling few of the parameters, the whole payload size will be decreased from 100 KB to 30 KB as an example. Broadly is a new one which offers better compression ratios than gzip, and it is also supported by modern clients and browsers. That's all about the compression, which is a quick win. Moving on to the sixth one, that is asynchronous logging. For high throughput systems where every millisecond counts, you can clearly see that the bottleneck is on logging. Time taken to write up logs can add up too fast for a heavy high throughput request. In this case, asynchronous logging can help. So in this representation, if you see, the first case is basically the logging is part of the actual business logic, and after synchronous logging only, you are returning the response. So in this asynchronous logging solution, main logic quickly places a log entry into the memory buffer, where separate worker writes logs to the disk or send them to any logging service. Small caveat can be we might lose some logs as it stores in memory, and at that point of time if the server crashes. And it's a trade-off you can decide. And there you have it. Top 6 ways where you can improve your API performance to 10x, faster and efficient. If you have any other techniques, please drop a comment so that we can all learn and improve. That's all for this video. If you love this content, make sure you hit that like button and subscribe. Thank you so much for watching, and I'll see you in the next one.